Right now, a machine the size of a small piano is falling through the dark beyond Neptune, so far from home that its radio whispers, moving at the speed of light, take hours to reach us. Its name is New Horizons. More than a decade ago, it did something no spacecraft had ever done. It reached Pluto. But reached is a generous word for what happened. After 9.5 years of falling outward, it tore past Pluto in a single afternoon at more than 30,000 miles an hour, took its photographs, and kept right on going, because it could not stop. It was never able to stop. And out there where it flew, the sun is no longer a sun, it is just the brightest star in a black sky, so far away that noon on Pluto is darker than dusk back here. That is how far away it is. So far that the thing warming your face right now would be a single point of light you could hide behind your thumb. The question I want to ask tonight is whether we could ever truly follow it out there. Tonight, we are going to follow that journey all the way out and find out what it would really take for humanity to reach Pluto. By the end of this, you will understand exactly how far Pluto is and how long the crossing takes, what you would pass and what you would have to survive on the way, and why stopping there is harder than getting there at all. And you will understand what is actually waiting at the end of that long dark, because the world New Horizons found is nothing like the dead grey rock that everyone expected. If you like the kind of question that pulls you all the way to the edge of the solar system, a subscribe is how you keep them coming. Now let us begin. Start with the number, because the whole problem begins there. Pluto sits, on average, about 3.7 billion miles from the Sun. That is roughly 39 times farther out than we are. Take the distance from here to the Sun, the gap that already feels impossibly large, and lay it end to end 39 times, and only then do you reach Pluto. And that is just the average, because Pluto does not travel in a neat circle the way Earth nearly does. Its path is stretched and tilted, carrying it from about 30 times Earth's distance at its closest to nearly 50 times at its farthest, over a single slow loop around the Sun that takes 248 years. One Plutonian year is longer than the entire history of most countries. No human being has lived to see Pluto return to where it was when they were born. Here is the cleanest way to feel that distance, and I am going to come back to it again and again tonight, because it is the truest measure of the whole journey. Light is the fastest thing there is. Sunlight crosses the gap from the Sun to your face in about 8 minutes. That same sunlight racing outward at 186,000 miles every second takes about 5.5 hours to reach Pluto. 5.5 hours at the speed of light just to arrive. When you look at Pluto, you are looking at a place so distant that the Sun itself needs most of a working day to get there. And when that light finally arrives, there is so little of it left. This is the image I want you to hold on to for the entire video, because it carries the whole argument. The Sun. From here, the Sun is the brightest, hottest thing in the sky, a disk you cannot even look at, pouring warmth onto your skin. From Pluto, the Sun is a star, not the warm disk we know, but a single brilliant point of light among the others, so far away and so small that you could lift your thumb and cover it completely, and behind your thumb would be everything that has ever warmed a living thing. Pluto receives somewhere between 1/900th and 1/1600th of the sunlight that falls on Earth. Stand on Pluto at high noon, with the Sun as high as it ever climbs, and the light around you would be dimmer than our twilight, the grey half-light of the minutes after sunset here. Noon out there is darker than dusk back home. That is the world we are asking whether we could reach. Not a brighter, colder version of our own neighbourhood, but a place where the Sun has shrunk to a point and the day is permanent dusk. So cold, at that distance, that the surface sits near -230 degrees, cold enough that gases we breathe would freeze solid and fall as frost. This is the gap the word far was always hiding. We say Pluto is far away, we say another country is far, and the two have nothing to do with each other. I want to be honest about one wrinkle right at the start, because it matters for any real mission. There is no single distance to Pluto, because its orbit is so stretched, and because Earth is also moving. The gap between us and Pluto is always changing, swinging by more than 1 billion miles depending on where both worlds happen to be in their loops. Plan a trip, and you are not aiming at a fixed point. You are aiming at a slow-moving target across a distance that itself keeps shifting. Even the question, how far is Pluto, does not have one clean answer. Let me make that distance even more concrete, because the numbers are so large they start to blur together. Astronomers measure distances out here in a unit called the astronomical unit, which is simply the distance from Earth to the Sun, about 93 million miles. Earth, by definition, is one of these units from the Sun. Jupiter is about 5, Saturn about 9.5, Neptune, the farthest of the great planets, about 30, and Pluto, on average, about 39, swinging out to nearly 50 at the far end of its orbit. So Pluto is not a little past Neptune. At its most distant, it is well over half again, as far out as the last giant planet, in a part of the solar system the major planets never reach. There is a strange wrinkle in that orbit worth knowing, because it shows just how unlike the planets Pluto really is. Pluto's path is so stretched and tilted that for a stretch of each long orbit, it actually swings in closer to the Sun than Neptune does, ducking briefly inside the orbit of the last great planet before swinging back out. It happened most recently for about 20 years around the 1990s, when Pluto was, for a while, not the most distant known world at all. The two never collide, because their orbits are locked in a careful rhythm that always keeps them far apart, Pluto circling the Sun twice for every 3 times Neptune goes around. But it tells you something that the so-called 9th planet crosses the orbit of the 8th. Pluto never really belonged to the orderly procession of planets. It moves on its own stretched, tilted path, a visitor from the colder, wilder population of worlds beyond. And come back one more time to light, because it is the thing that makes the distance real. A radio signal is light. When New Horizons flew past Pluto and took its photographs, those pictures had to be beamed home as radio, crawling back across the solar system at the speed of light, and even at that speed each image took about 5.5 hours to arrive. Send a command out to the spacecraft, and it would not even receive it for 5.5 hours, and you would not know whether it worked for another 5.5 hours after that. 11 hours, there and back, at the fastest speed the universe allows, just to ask the machine a single question and hear its answer. We are so used to talking to each other instantly that this is hard to feel, but it is the plain reality of Pluto's distance. Out there, even light is slow. Even light takes most of a day to come and go. That is the gap we are asking whether a heavy, fragile, human-carrying ship could ever cross. It can help to shrink the whole thing down to something you can picture. Imagine the Sun reduced to the size of a basketball. On that scale, Earth would be a grain of sand about 30 paces away. Jupiter would be a marble a good city block out, and Pluto would be a nearly invisible speck of dust, more than 1 kilometre from the basketball Sun, creeping along at the dim outer limit of the whole arrangement. At that range, the basketball Sun would itself look small, and the warmth it threw would be nothing. That is the real geometry of where Pluto lives. Not a near neighbour just past Neptune, but a mote of dust at the cold far edge of a model that, scaled to real distances, would stretch across a whole landscape. Every honest attempt to picture the solar system to scale ends the same way, with the inner planets clustered near the middle and the outer worlds, Pluto last of all, marooned far out in a darkness that the diagrams never have room to show. And the day out there would feel strange too. Pluto turns slowly, taking about 6.5 Earth days to complete a single rotation. So a day on Pluto, one sunrise to the next, lasts almost a week of our time. Not that sunrise would mean much, with the Sun a mere point that never warms anything. You would watch that bright star crawl across the sky over the better part of a week. throwing long, faint shadows across the nitrogen ice, and then sink again into a night that also lasts for days, under a sky full of stars with Charon hanging motionless among them. Slow days, slow years, a slow cold world turning at the edge of the light. If it helps to measure the distance in human terms, try this. A passenger jet cruising at about 500 miles an hour, flown without ever stopping, would take roughly 800 years to fly the distance from Earth to Pluto. 800 years of continuous flight. Generations of pilots living and dying in the air, just to cross the gap once. Drive it in a car at highway speed, and you would need something like 6,000 years, longer than all of recorded history, to arrive. These are absurd numbers, and that is exactly the point. The distance to Pluto is so far outside the scale of any travel we know that our fastest everyday machines would need centuries or millennia to cross it. Only a spacecraft flung at tens of thousands of miles an hour brings the trip down to a mere decade, and even then, a decade is the price. There is no quick way, there is no shortcut. There is only the distance and the long patience it demands. And there is one more thing the distance does that is easy to miss. It makes Pluto faint. So little sunlight reaches it, and so little bounces back toward us, that for the better part of a century after it was first spotted, Pluto was nothing more than a single dim point of light, too far and too small for even our best telescopes to show as anything but a fuzzy dot. We knew almost nothing about it, not its true size, not its colour, not a single feature on its surface, because at that distance it gave back so little light that there was nothing to see. Everything we now know about what Pluto actually looks like, the heart, the mountains, the haze, all of it, we learnt only when we finally crossed the distance and sent a machine close enough to look. That is what the gulf to Pluto meant for most of the time we have known the world existed. Not a place we could study, but a faint speck at the limit of sight, holding all its strangeness in reserve until we found a way to go. So that is the scale of it. Light takes 5.5 hours. The sun becomes a star. Noon becomes dusk. The surface freezes the air. Which leaves the obvious question, the one this whole video is built to answer. If the distance is that enormous, how on earth do you cross it? How do you move something real, something built and heavy, across a gap that swallows even light for half a day? We have actually crossed that gap once. And the way we did it tells you everything about how hard it is. The machine was called New Horizons, and it left Earth in 2006 as the fastest spacecraft ever launched, tearing away from our planet at about 36,000 miles an hour. Nothing built by human hands had ever left at that speed. It crossed the orbit of the Moon, a trip that took the Apollo astronauts 3 days, in about 9 hours. If raw speed at launch were the whole story, Pluto should have been a quick trip. It was not. Because even 36,000 miles an hour, the fastest we had ever managed, was not nearly enough on its own. To shorten the trip, New Horizons did something clever. In 2007, it swung close past Jupiter, the largest planet in the solar system, and stole a little of the giant's motion, slingshotting off its gravity to pick up speed and bend its path outward. That single maneuver shaved around 3 years off the journey. 3 years, saved by one well-aimed pass at one giant planet. And even with that boost, even launched faster than anything before it and flung onward by Jupiter itself, the crossing still took 9.5 years. 9.5 years. A child born the day it launched would have been most of the way through grade school before it arrived. It coasted outward through 2008, 2010, 2012, most of that time asleep, its systems shut down to rest, waking only for occasional checks, falling silently through the dark the entire time. And then, in July of 2015, after all those years, it finally reached Pluto. And here is the catch that defines this entire video. It did not stop. It could not stop. After 9.5 years of falling, New Horizons flew through the whole Pluto system, in a single afternoon, racing past the surface at more than 30,000 miles an hour, grabbing every photograph and measurement it possibly could in those few precious hours, and then it was gone, past Pluto, hurtling on into the dark beyond, where it still flies today, getting farther away every second. All those years to get there, and the actual encounter, the part everyone waited for, lasted about as long as an afternoon. Think about what that really means. We did not visit Pluto the way you visit a place. We sprinted past it, snatched what we could as it blurred by, and kept going, because there was no way to do anything else. The fastest, most carefully aimed machine we have ever sent into deep space reached its target and was physically unable to stay. That is not a small detail. That is the heart of the problem, and we will spend a good part of tonight on why it happened and whether it could ever be different. I should be fair and note that New Horizons no longer holds the outright speed record. A later craft, the Parker Solar Probe, has since moved faster, but it did so by falling inward toward the Sun, diving into the Sun's gravity well, which is the opposite of what you want when you are trying to climb all the way out to Pluto. For the job of heading outward, across the solar system to its frozen edge, New Horizons is still the benchmark, the fastest real attempt we have ever made. And the benchmark could only manage a flyby. It is worth sitting with just how fast 36,000 miles an hour really is, and why even that was not enough. At that speed, you would cross from one side of Earth to the other in about 20 minutes. You would get from the Earth to the Moon 250,000 miles in roughly 9 hours, a trip that took the Apollo crews 3 days. By every standard of human travel, it is an absurd, blistering speed. And against the distance to Pluto, it is a cruel 3.7 billion miles, even at 36,000 miles an hour, is the better part of a decade, because the gap is so enormous that the fastest launch we have ever achieved still gets swallowed by it. That is the thing to understand about Pluto. It is not that our rockets are slow. The distance is simply so large that it makes even our fastest machines look like they are barely moving. The trick that saved 3 years, the swing past Jupiter, is worth understanding too, because it is the only reason the trip was under a decade at all. When a spacecraft flies close to a giant planet, it can be flung forward by the planet's gravity, stealing a tiny share of the giant's own motion around the Sun and adding it to its own speed. The planet loses an utterly negligible amount, far too small to ever measure, and the little spacecraft gains thousands of miles an hour. New Horizons did exactly this at Jupiter, falling toward the giant, whipping around it, and coming away faster and aimed outward at Pluto. It is a kind of slingshot, free speed borrowed from a planet, and almost every mission to the outer solar system relies on it, because building a rocket powerful enough to do the same job with fuel alone is beyond us. We do not have engines that can simply power their way to Pluto at speed. We have to beg a boost from Jupiter along the way. And here is a detail that quietly drives home the distance all over again. When New Horizons flew past Pluto and filled its memory with photographs and measurements in that single afternoon, it could not send them all home quickly. The signal was so faint after crossing billions of miles, and the data so plentiful, that it took about 15 months, more than a year, to trickle every last image and reading back to Earth. The encounter lasted an afternoon. The downloading of what it saw lasted well over a year. That is what the distance does even to information itself, even to light. It stretches an afternoon's worth of pictures into more than a year of patient listening, because that is how long it takes to whisper that much across the gulf between here and Pluto. It is worth knowing just how small a thing crossed all that distance, because it reframes the whole achievement. New Horizons is not some enormous ship. It weighs about as much as a grand piano, a compact little machine you could fit in a small room, carrying just 7 instruments and a dish to talk to home. Part of why it could be flung so fast is precisely that it was so light, because a lighter craft is easier to accelerate to high speed. But that lightness is also exactly why it could never stop, because there was no room aboard a piano-sized probe for the mountains of fuel that stopping would have demanded. The very thing that let it get to Pluto quickly is the thing that doomed it to fly straight past. Speed and stopping pull in opposite directions, and New Horizons was built entirely for speed. And it is still out there, still going. Years after the flyby, New Horizons continues to fall outward, now far beyond Pluto, still sending back faint signals as its nuclear power source slowly fades. Sometime in the years ahead, that power will dwindle too low to run the instruments, and the little machine will fall silent, coasting on forever through the dark with no one listening. The way the Voyager probes before it will eventually go quiet too. It will not stop then either. Nothing out there will stop it. It will simply keep falling outward through the emptiness, past the edge of everything we have explored, a silent piano-sized messenger, carrying its long-finished mission into a dark it will never leave. The slingshot off Jupiter is worth one more thought, because of what it tells you about our limits. We did not reach Pluto in under a decade by building a more powerful rocket. We reached it by borrowing speed from a planet, because building an engine strong enough to do the same job on its own is beyond anything we have. Think about what that means. The single fastest, most determined push we have ever made toward the outer solar system still had to lean on Jupiter's gravity for a free boost. Like a swimmer grabbing a passing current because they cannot swim fast enough alone. Without Jupiter sitting in the right place, the trip would have taken 3 to 5 years longer still, or might not have been practical at all. That is how close to the edge of our ability even the New Horizons flyby was, a mission that succeeded partly because the giant planet happened to be lined up to help. We are not masters of these distances. We are careful travelers who time our departures to catch a push from the worlds along the way. Because on our own power alone, the gulf to Pluto is almost more than we can manage. So New Horizons reached Pluto and then could not stop and flew on past in a single afternoon. That was not bad luck, and it was not a mistake. There is a reason no spacecraft has ever stopped at Pluto, a reason it is genuinely harder to stop there than to cross the billions of miles to get there in the first place. I will come back to it, and when I do, it changes what reaching Pluto even means. So you launch, and you fall outward for years. What do you actually cross on the way? The answer is not what most people picture, and the first surprise comes early, just past Mars. Between Mars and Jupiter lies the asteroid belt, and in films it is always a churning storm of tumbling rock, a place you have to weave through at high speed while boulders slam past on every side. That image is almost entirely wrong. The asteroid belt is real, and it holds a great many rocks, but they are spread across such an enormous volume of space that they are on average hundreds of thousands of miles apart. You could fly straight through the heart of the belt and never come close to a single one. Every probe we have ever sent to the outer solar system has sailed right through it without trouble, New Horizons included. The belt is not a wall, it is mostly emptiness with a few scattered rocks lost in it. The real danger on the way out is not the rubble, it is the giant. Jupiter, the largest planet in the solar system, is the same world whose gravity gives the free speed boost, but getting close enough to use it means flying into one of the most hostile places in the solar system. Jupiter is wrapped in belts of intense radiation, zones of charged particles trapped and accelerated by its enormous magnetic field, fierce enough to fry the electronics of a spacecraft that lingers too long or flies too close. A ship using Jupiter for a boost has to thread the needle, getting near enough to steal speed, but not so near that the radiation kills its systems. The thing that helps you on your way is also one of the few things out here that could end the mission outright. Past Jupiter, the journey becomes a slow march between widening milestones. Saturn, with its rings, lies far beyond Jupiter. Uranus lies far beyond Saturn. Neptune lies far beyond Uranus, and the gaps between them are not even. Each step outward is bigger than the last, the planets spreading farther and farther apart the deeper you go. as if the solar system is stretching thin toward its edge. At each of these worlds, if you paused to look back, the Sun would be smaller than it was at the one before. By the time you reach Neptune, the outermost of the major planets, the Sun gives only about 1,000th of the light it pours onto Earth, a single hard bright point with no warmth left in it at all. The shrinking has already gone most of the way. And here is the part that resets your sense of scale. New Horizons crossed the orbit of Neptune in 2014. Neptune, the last of the great planets, the edge of the familiar solar system, and it was still nearly a year of travel short of Pluto. Even after passing the final giant, after 8 years of falling, there was another year of empty dark still to go. That is how much farther out Pluto sits than even Neptune, the world we usually think of as the end of the line. So the crossing is not a quick dash past crowded hazards. It is a long fall through a mostly empty solar system, with one genuinely dangerous giant to slip past, and a string of ever more distant worlds marking how far you have come. We have charted this whole route, sent real machines past every one of these planets, so the path itself is known. But knowing the path is not the same as travelling it with people aboard. No human being has ever gone even a fraction of this far. The farthest any person has ever travelled from Earth is the Moon, a trip of 3 days. Everything past that, this entire route has only ever been crossed by robots. The emptiness of the asteroid belt is worth dwelling on, because it is one of the most stubborn, wrong pictures people carry about space. If you gathered up every single asteroid in the belt, every rock from the largest down to the smallest, and rolled them all into one ball, that ball would be less than the mass of our moon. All of it, the entire famous belt, would not even make a respectable moon, and that small amount of material is spread across a ring of space so enormous, hundreds of millions of miles around and tens of millions of miles wide, that the rocks end up impossibly far apart. If you were standing on one asteroid, the nearest other one would usually be too far away to see as anything but a faint star, if you could see it at all. The dramatic field of tumbling boulders exists only in films. The real belt is one of the emptiest places a spacecraft ever crosses, and New Horizons passed through it without the slightest trouble, never coming near a thing. Jupiter, on the other hand, earns every bit of its danger. The giant is wrapped in a magnetic field so enormous that if you could see it from Earth, it would appear larger in our sky than the Moon, a structure millions of miles across. That field traps charged particles and accelerates them into belts of radiation fierce enough to kill electronics, and to kill a person outright in a fairly short time. A spacecraft using Jupiter for a speed boost has to choose its path with great care, getting close enough to the giant to steal the slingshot, but staying clear enough of the worst of those radiation belts to survive the pass. It is a genuine threading of a needle, a careful trade between the speed you need and the radiation that could end the mission. The same giant that helps you on your way is one of the most lethal places in the entire solar system. And past Jupiter, the thing that struck me most as I traced the route is how the solar system stretches. The gap from the Sun out to Jupiter is large. The gap from Jupiter to Saturn is larger. From Saturn to Uranus larger still. From Uranus to Neptune larger again. Each step outward is bigger than the one before, the worlds spreading farther and farther apart, so that the solar system is not an evenly spaced row of planets but a structure that thins and opens up as you go, the outer worlds scattered across gulfs far wider than the cozy inner system most of us picture. By the time you are out among the giants, you are crossing distances between neighbours that dwarf the entire span from the Sun to Earth. And Pluto sits beyond even that, past the last of the widening gaps, out where the spacing has opened up into something close to empty. The worlds you pass on the way are not just markers, they are destinations in their own right that a Pluto-bound ship simply has to ignore. Saturn hangs out there with its rings, the most beautiful structure in the solar system, and a ship to Pluto sails past it without stopping. Uranus, tipped over on its side so that it rolls around the Sun like a ball, goes by. Neptune, deep blue and lashed by the fastest winds of any planet, goes by. Each of these is a world we have visited only briefly, that we would dearly love to study for years, and the trip to Pluto crosses right past all of them with barely a glance, because stopping at any one would cost years and fuel the mission cannot spare. That is its own kind of strange, to fall past some of the grandest worlds in the solar system, treating them as nothing more than distance markers on the way to something farther still. It is worth saying that we have crossed this whole outer route before, more than once. 2 Voyager spacecraft made similar journeys decades ago, threading past the giant planets one by one and continuing outward, and they are still going, now far beyond Pluto's distance, the most remote machines we have ever launched. They took their own long years to cross the outer system, and they too could only fly past each world they met, never stopping, because they faced the very same wall of speed and fuel. So the route to Pluto is not unknown territory. It is a path a handful of our machines have now travelled, each of them taking the better part of a decade or more. Each of them a flyby, none of them ever able to stop. Every robot that has gone this far has gone as a passing visitor, because passing is all the distance allows. There is a reason these missions are timed so carefully, and it comes back to that planetary slingshot. The boost from Jupiter only works when Jupiter is in the right part of its orbit, lined up between where you launch and where you are going. That alignment comes around only every so often, which means there are narrow windows, years apart, when a fast trip to Pluto is even possible, and long stretches between them when it is not. Miss the window and you wait, sometimes a decade or more, for the giant planet to come back into position. So a journey to Pluto is not something you can simply launch whenever you decide to go. It is a rare opportunity that opens briefly, depending on where the giant planets happen to be, and closes again for years. The outer solar system sets the schedule, not us. Even our ability to attempt the crossing at all is rationed by the slow wheeling of distant worlds. We have no power to hurry. It is humbling to realize that everything beyond Mars, this entire route we have been tracing, has only ever been crossed by a handful of robots, and never by anyone alive. A few small machines, over the past 50 years, are the sum total of everything that has travelled this far from home. The asteroid belt, Jupiter's radiation, the widening gaps between the giants, the long fall past Neptune, all of it has been witnessed only by cameras and instruments, never by a living eye. When New Horizons photographed Pluto, no human being was within 3 billion miles of the place, and none ever has been. The farthest any person has gone remains the Moon, a destination so close on this scale that it is practically in our own backyard. Everything past it, this whole enormous outer solar system, belongs so far to the machines alone, and the question of whether a person could ever follow them out is exactly the question this video keeps circling back to. Which brings us to the emptiest and hardest part of the whole journey, the part the planets were hiding. Once you pass Neptune, the milestones run out. There are no more giants, no more rings, no more worlds to mark the way. There is just the long dark, and it is longer and darker than anything that came before. Past Neptune, the solar system empties out. This is the stretch nobody pictures when they imagine going to Pluto, and it is the part that would be hardest to survive, because there is almost nothing out here at all. The worlds are behind you. Ahead is a gulf of dark so wide that the nearest large object might be hundreds of millions of miles away in any direction, and a ship simply falls through it for years with nothing to see and nothing to do but keep its systems alive and wait. The cold out here is not the cold of a winter night. It is the cold of deep space, where any surface turned away from that distant pinprick sun drops toward -230 degrees, cold enough to freeze the air in your lungs solid, cold enough that the nitrogen we breathe would lie on the ground as frost. A ship crossing this region has to make and hoard its own warmth the entire way, because there is no warmth to be had outside it. None. Not from a sun that now gives 1,000th or less of what it gives at Earth. The shrinking has reached its end. Out here, the sun is no longer something you feel. It is only something you can find, if you know where to look, a single bright star among the others. And then there is the silence, which might be the hardest part of all for a human crew. Out at Pluto's distance, a radio message moving at the speed of light takes about 5.5 hours just to reach Earth, and any reply takes 5.5 hours to come back. Ask a question of home, and the answer is most of a day away. There is no conversation possible at that range, no quick call for help, no expert talking you through a crisis in real time, because by the time your words arrive and a reply returns, 11 hours of your emergency have already passed. Anyone out here is alone in a way that nothing on Earth can match, severed from the rest of the human race by hours of crawling light, with the nearest other people farther away than any humans have ever been from one another. This is the region the whole journey was really about, and it is why I keep returning to that shrinking sun. The planets and the milestones were a distraction. The truth of the trip to Pluto is this long, cold, silent fall through a dark where the sun is just a star and home is hours away even at the speed of light. New Horizons spent most of its 9.5 years exactly here, coasting through this emptiness, mostly asleep because there was simply nothing else to do but endure the distance. A machine can sleep through it. It feels no cold, no fear, no loneliness, no slow grind of years in the dark. A person is a very different kind of cargo. And that is the thing we have never tested. We do not actually know whether human beings could endure years of this. The confinement, the cold pressing in on every wall, the sun reduced to a star, the nearest help half a day away by light and many years away by any ship. Every machine that has made this crossing carried no one. It needed no air, no food, no company, no hope. The human version of this journey, a crude ship falling for a decade or more through the outer dark, has never been attempted, and everything about it, from the life support to the sheer psychological weight of that isolation, is unproven. There is a practical problem in the long dark that almost no one thinks about, and it comes straight from the shrinking sun. Out near Earth, a spacecraft can run on sunlight, spreading wide panels to catch the sun's energy and power everything it does. Out past Neptune, that stops working. The sun is so faint there, 1,000th or less of its strength at Earth, that solar panels become almost useless, starved of the light they need. So a ship crossing to Pluto cannot run on sunlight at all. It has to carry its own power source the entire way, almost certainly something nuclear, a generator that turns the heat of slowly decaying material into electricity, year after year, through the dark. New Horizons does exactly this, drawing its power from a lump of warm radioactive material, because out at Pluto's distance there is simply not enough sunlight left to run a spacecraft. The sun has dwindled so far that it can no longer even keep the lights on. And that same faintness is why the cold is so absolute. Warmth out here has to be made and hoarded. Every degree of heat keeping the machine's delicate parts from freezing solid has to come from inside it, because nothing outside will provide it. A ship carrying people would face this problem enormously magnified, needing to hold a warm, livable space against a cold near -230 degrees for years, with the only heat being whatever it brought along or generated on board. The dark between the worlds is not neutral. It is actively pulling the warmth out of anything that crosses it, every second the whole way, and only a constant supply of made heat keeps a ship from freezing into a dead lump of metal. But the hardest part of the long dark might not be the cold or the power at all. It might be what it does to a human mind. We have sent people to the moon 3 days away, and we have kept them in orbit just above the Earth for a year or more, with the blue planet filling the window the whole time, help only hours away. No one has ever been truly far from home, truly cut off, the way a crew bound for Pluto would be. Years in a sealed ship, the sun shrunk to a star, the Earth long since lost to view, every message home taking hours each way, the nearest other human beings receding farther behind with every passing day. We do not know how a person endures that, because no person ever has. The body we might keep alive with enough engineering. The mind, across a decade of that emptiness, is the genuine unknown, and it is the kind of unknown you cannot test without actually sending someone out into the dark to find out. There is a problem of supplies that quietly dwarfs almost everything else about a crewed trip. A machine needs no food, no water, no air. A crew of people needs all three every day for the entire length of the journey. And a journey to Pluto and back could run 20 years or more. 20 years of breathable air, of drinkable water, of food, for every person aboard, either carried from the start as an enormous mass of stores, or somehow grown and recycled in a sealed loop that has to work flawlessly for decades, with no resupply. We have never built a system that can do that. The longest anyone has lived off-world is a stretch of months aboard a station circling just above the Earth, constantly restocked by ships from below. Cut that lifeline, send the same people years out into the dark where no resupply can ever reach them, and every failure becomes final. A broken part, a failed crop, a leak of air, with no way to send help and no way to turn back in time, and the whole crew is simply lost. This is the quiet truth underneath the dream of crossing the solar system. The distance does not only have to be crossed, it has to be survived day after day for years by fragile bodies that need a constant supply of everything a living thing needs, in a place that provides none of it. The machine slept through its 9.5 years feeling nothing. A human crew would have to stay alive and whole through every single one of those days, awake to all of it, with the nearest help receding farther behind them the whole way. When people picture going to Pluto, they picture the arrival. The real challenge is the thousands of ordinary days in between, each one of which has to go right. There is also the steady, invisible danger of radiation across all those years. Space is filled with fast-moving particles flung out by the sun and by violent events far across the galaxy, and out beyond the protection of Earth's magnetic field, a crew would be exposed to them continuously for the entire length of the trip. A machine shrugs most of this off, a human body does not. Years of that exposure raise the risk of cancer and can damage the body in ways we are only beginning to understand. And there is no easy shield, because blocking the particles takes heavy material, and heavy material is more mass to haul across the solar system, feeding straight back into the fuel problem that haunts every part of this. So a crew bound for Pluto would be slowly irradiated the whole way out and the whole way back, with no way to fully stop it, another quiet cost of spending years in the dark that a robot simply never has to pay. Everything that makes a person, a body that breathes and ages and heals, becomes a liability across a journey this long. And there is the simple, grinding matter of time itself, measured against a human life. A robot does not age in any way that matters, and a decade in transit costs it nothing. For a person, a decade is 1/10 of a long life, and a round trip of 20 years or more is a substantial fraction of all the years they have. A crew bound for Pluto would be spending a real and irreplaceable piece of their lives simply crossing the gap, years that pass in a sealed ship in the dark, with nothing of the world they left and nothing yet of the world ahead. They would arrive older, having given up a decade to the journey, and if they ever returned they would come back to an Earth that had moved on 20 years without them. Friends aged, the world changed, themselves strangers to the time they came home to. The distance is not only measured in miles or in fuel, it is measured in years of a human life, spent in the crossing, and that is a price no machine has ever had to weigh. So you fall through the long dark for years, cold and silent and alone, and at last, ahead of you, a faint point begins to grow. Pluto, the place you cross the entire solar system to reach. And now the most important question of the whole trip arrives, the one I told you to hold on to. When you finally get there, can you actually stop? Or do you do what New Horizons did and tear past it in a single afternoon, having come all this way only to wave as you fly by? Here is the answer, and it is the reason no one has ever stopped at Pluto. Arriving at Pluto and stopping at Pluto are two completely different problems, and stopping is by far the harder one. This is the wall I told you to hold on to, and it is worth understanding exactly, because it is the single biggest obstacle between us and that frozen world. Think about what you have done by the time you reach Pluto. You have spent years building up an enormous speed, tens of thousands of miles an hour, all of it carrying you outward. To actually stop at Pluto, to slip into orbit around it or settle onto its surface, you have to get rid of all that speed, every bit of it. And shedding speed in space is not like braking a car, because there is no road to push against, no friction, nothing to grab. There are really only two ways to do it, and Pluto takes both of them away from you. The first way is to turn your ship around and fire your engines against your own motion, burning fuel to cancel out your speed. This works, but it is brutally expensive, because slowing down costs just as much as speeding up did. To stop at Pluto, you would have to carry all the fuel needed to kill your speed at the far end, the whole way there, across 9.5 years and billions of miles, hauling that dead weight of braking fuel through the entire crossing. And carrying more fuel makes the ship heavier, which means you need still more fuel to move it at all, a vicious spiral that quickly becomes impossible. The arithmetic of it defeats you before you even launch. The second way is the trick we use at other worlds. You dip into the target's atmosphere and let the air itself slow you down, friction bleeding off your speed so you do not have to spend fuel doing it. We do this at Mars, at Earth, at any world with real air, but Pluto has almost no atmosphere to speak of. Its air is so thin that the pressure at the surface is about 100,000th of the pressure you are feeling right now. That is not air you could brake against. That is barely more than empty space. Try to use it to slow down and you would feel essentially nothing. Just sail straight through it and out the other side, still moving at thousands of miles an hour. And Pluto cannot even help you with its gravity, because there is so little of it. Pluto is small, smaller than our own moon, and its surface gravity is only about 6% of Earth's. It barely pulls at all. A world with strong gravity can grab a passing ship and swing it into orbit. Pluto does not have the grip to do that. It cannot catch you. So you arrive having spent years crossing the void, and the world you came all that way to reach offers you nothing to stop against. No thick air, no strong pull, no way to shed the speed that carried you here. This is exactly why New Horizons did not even try to stop. It was never designed to. From the very beginning it was built as a flyby, a single high-speed pass, precisely because the alternative, hauling enough braking fuel across the entire solar system to halt at a world that gives you nothing to brake against, was so close to impossible that no one seriously attempted it. The mission planners did the arithmetic, saw the wall and accepted the afternoon glimpse instead, because an afternoon glimpse was what the physics allowed. So the distance was never the only wall. The arrival is its own wall, and in some ways a worse one. You can throw enough speed at the distance to eventually cross it, given years and patience. But that same speed becomes your enemy the instant you arrive, and Pluto hands you no way to be rid of it. This is the vertiginous heart of the whole question. You can cross the entire solar system, do everything right, fall for a decade through the cold and the dark and the silence, and still the universe will not let you stop at the end of it. The reaching was the easy part. The staying is what breaks you. I want to be straight about what could change this. There are real proposals on paper for a mission that would actually orbit Pluto rather than flash past it. But every one of them runs straight into this wall. To stop, they would need to either carry enormous amounts of fuel, which pushes the trip out to 20 or 30 years, or rely on engines we have not yet built, new kinds of propulsion that exist mostly in design studies. An orbiter around Pluto is possible in principle, and people are working on how it might be done. But it is hard in a way that getting there, the part we already managed, simply was not. And a ship carrying people, which has to be far heavier and far safer than any robot, makes every part of that wall taller. The reason carrying braking fuel is so punishing deserves a plain explanation, because it is one of the cruelest facts in all of spaceflight. Fuel has weight. To slow a ship down at Pluto, you need a certain amount of fuel to fire against your motion, but that fuel has to be carried the whole way there, which means at launch you also have to lift it and accelerate it along with everything else, and lifting and accelerating that extra weight takes still more fuel, which itself has weight, which takes more fuel again. The demand snowballs. Every kilogram you want to stop with at the far end costs you many kilograms of fuel to carry across the solar system to get it there. This is why slowing down is treated as roughly as expensive as speeding up, and why a mission that has to both reach Pluto and stop there needs so much more than one that simply flies past. The flyby was not laziness. It was the only option the arithmetic allowed. It helps to see how we stop at other worlds, to feel what Pluto is missing. At Mars, landers slam into the thin upper atmosphere and use it to shed most of their speed before parachutes and rockets finish the job, all of it leaning on the air to do the heavy work for free. At Jupiter and Saturn, spacecraft can swing close to the giant and let its powerful gravity capture them into orbit, the planet doing the catching. Every successful arrival in the outer solar system has relied on one of these gifts: a thick atmosphere to brake against, or a strong gravity to be caught by. Pluto offers neither. Its air is 100,000 times too thin to brake against, and its gravity, at 6% of Earth's, is far too weak to capture anything moving at speed. A world that gives you nothing to stop with is a genuinely rare and difficult target, and Pluto is the farthest example of it. The worst combination of enormous distance and nothing to grab at the end. This is why the real proposals to do better than a flyby are so daunting. Designs have been studied for a spacecraft that would actually slip into orbit around Pluto and linger, mapping the whole world over years instead of a single afternoon, watching its seasons change. Every such design runs straight into the wall. To carry the fuel needed to stop, the trip stretches out to 20 or even 30 years, 2 or 3 times as long as New Horizons took, because a heavier, fuel-laden ship cannot be flung as fast. The alternative is to invent new engines, more efficient kinds of propulsion that could brake without hauling mountains of fuel. And those exist mostly on paper and in small experiments, not in any ship ready to fly. So an orbiter at Pluto is possible, and people are seriously working on how, but it sits at the very edge of what we can do, and a crewed ship, which must be far heavier and safer than any robot, makes every line of that arithmetic worse. There is a problem hiding behind the stopping problem that is worse still, and it is the one almost no one mentions. Getting there is one thing, stopping is harder. But if you send people, they presumably want to come home, and coming home means doing the entire thing in reverse. You would have to stop at Pluto, then later climb back up to speed to leave it, cross the whole solar system again, and slow down once more to arrive safely back at Earth. Every one of those steps costs fuel, and every bit of that fuel has to be carried, which means carrying the fuel to carry the fuel, the snowball growing at every stage. A round trip to Pluto with people is so far beyond a one-way robotic flyby that they are barely the same kind of undertaking. It is the difference between throwing a stone across a river and building a bridge you can walk both ways. This is why when people think seriously about sending humans to the farthest places, the honest plans often quietly become one way. No one wants to strand a crew. The trouble is that the fuel and supplies to bring them back multiply the difficulty so enormously that a return may simply be out of reach with anything we can currently build. And a one-way trip to Pluto is a different proposition entirely. Not an expedition, but an exile, a crew falling outward for a decade toward a frozen world they would never leave, to live out whatever remained of their lives under a sun the size of a star, with home forever hours away by light and unreachable by any ship. When you add the journey home to the journey out, the whole idea strains against the limits of the possible in a way that the single, simple flyby never did. Reaching Pluto is hard. Reaching it and coming back is something else again. It is worth contrasting Pluto with the two places we have actually reached or seriously planned to reach, because it shows why those were possible and Pluto is not, at least not yet. The Moon is close, a 3-day trip, with enough gravity to hold a ship in orbit and a surface near enough that a crew is never more than seconds from talking to home. Mars is far harder, months away rather than days, but it has real gravity to capture a ship and a thin atmosphere a lander can brake against, and at its closest the conversation lag with home is minutes, not hours. Both are genuinely difficult, and Mars in particular pushes the limits of what we can do. But both offer something to arrive at, a world that can catch you and hold you. Pluto offers none of that, and it is roughly 100 times farther than Mars. So the leap from the Moon to Mars, which is already enormous, is small next to the leap from Mars to Pluto. Each step outward into the solar system is not a little harder than the last. It is harder by a wide margin, and Pluto sits near the far end of that climb, past the point where our current tools can comfortably reach. I find the stopping problem strangely clarifying, because it reframes what space travel even is. We tend to think the hard part of going somewhere far is the going, the speed, the distance covered. Pluto teaches the opposite lesson. Getting up to speed and crossing the gulf, given enough years, is the part we can manage. It is the arriving, the shedding of all that hard-won speed at a world with nothing to brake against, that defeats us. In a sense, the universe is happy to let you go fast. What it charges dearly for is stopping. A thrown stone crosses a great distance easily, but it cannot choose to halt in the middle of the air, and a spacecraft falling toward Pluto is closer to that thrown stone than to a car that can simply slow and park. Once you understand that, the single afternoon New Horizons spent at Pluto stops looking like a disappointment and starts looking like exactly what the physics permitted, the most any flung stone could do as it passed. To do more, to stop and stay, is to fight the deepest grain of how movement works out there, and that fight is the real frontier. But suppose you solved it. Suppose you carried the fuel, or built the engine, and you actually stopped, and you stood on that surface under a sun no bigger than a star. What would be waiting for you there? Because the world New Horizons found, in its one rushed afternoon, was not the dead grey rock anyone expected. It was something far stranger and far more alive. Pluto should be dead. Everything about it says so. It is tiny, smaller than our moon, 4 billion years old, and so cold its surface sits near -230 degrees. A world like that should be a frozen, battered relic, its surface saturated with craters from billions of years of impacts, geologically finished, nothing moving, nothing changing, a corpse that stopped doing anything interesting eons ago. That is what every expert expected to see, and when New Horizons sent back its pictures, that expectation collapsed. The most famous thing it found is a huge pale shape, a region so distinct it looks almost drawn on, that quickly got nicknamed the heart. The left half of that heart is the part that broke the old assumptions, a plain called Sputnik Planitia, and it is one of the strangest landscapes in the solar system. It is a basin roughly 1,000 kilometers across, filled not with water ice, but with frozen nitrogen, the same nitrogen that makes up most of the air you are breathing, here lying in a frozen sea kilometers deep. And that frozen nitrogen is moving. Slowly, over ages, the ice is churning, warmed very slightly from below, rising in the middle of great cells, and sinking at their edges, turning over and over, like the surface of a simmering pot frozen almost to a standstill. You can see the cells in the images, a pattern of pale polygons fitting together across the whole plane, each one a slab of slowly overturning ice. Here is how we know it is alive. There is not a single impact crater anywhere on Sputnik Planitia, not one. Everywhere else in the solar system, old surfaces are covered in craters because over billions of years everything gets hit. A surface with no craters is a surface that is being constantly remade, wiped clean and resurfaced faster than the impacts can mark it. Which means this plane is astonishingly young. The ice you would be standing on is, in places, less than 10 million years old, and possibly far younger than that, a fresh surface on a world that is billions of years old. Something out there, on the coldest frontier of the solar system, is still actively paving the ground. And nitrogen, out at Pluto's temperatures, does the work that water does here. On Earth, water freezes into glaciers that flow downhill, carving valleys and filling basins. On Pluto, it is far too cold for that. But nitrogen takes over the role, freezing into glaciers of solid nitrogen that genuinely flow, creeping across the land, spilling into Sputnik Planitia from the highlands around it in great frozen streams. In the New Horizons images you can see the flow lines, the unmistakable signature of glaciers in motion, except these are glaciers of frozen air. A whole landscape shaped by the slow movement of ices we normally only meet as gases. Around the edges of all this rise the mountains, and they are made of the one material that stays hard out there: water ice. At -230 degrees, water ice is not soft and slick like the ice in a freezer. It is hard as rock, hard enough to build mountains, and Pluto has them. Ranges of water ice peaks standing 2 to 3 kilometers tall, as high as Sirius mountains on Earth, jutting up at the margins of the nitrogen plains. They are mountains in every real sense, except that the bedrock they are carved from is frozen water rather than stone. And in other regions there are stranger things still. Fields of dunes, made not of sand but of grains of frozen methane, shaped into ridges by the faint winds of that thin atmosphere. Dunes, on a world where the air is barely there at all. The churning of Sputnik Planitia is worth slowing down on because it is one of the most surprising processes anywhere in the solar system. The frozen nitrogen filling that 1,000-kilometer basin is kilometers deep, and it is warmed ever so slightly from below by Pluto's faint internal heat. That tiny warmth is enough to make the ice slowly convect, the way a thick soup turns over on a low flame. Warmer ice rising slowly in the center of each cell, and cooler ice sinking back down at the edges. Each full turnover takes something like 500,000 years, almost unimaginably slow by the standards of a single life, but quick enough, over the long history of Pluto, to keep wiping the surface clean. The pale polygons you can see in the photographs are the tops of these cells, each one a slab of ice, slowly overturning, and where they meet, blocks of harder water ice float on the denser nitrogen like rafts, carried along on the creep of the frozen sea. It is a landscape that is, very slowly, alive with motion. The lack of craters is the proof, and it is worth being clear about why that matters so much. Across the solar system, age is written in craters. An old dead surface, like the highlands of our own moon, is saturated with them, every patch scarred by billions of years of impacts. So when a surface shows no craters at all, there is only one explanation. It is being remade faster than the impacts can accumulate, resurfaced again and again, kept forever young. On Sputnik Planitia, the count of craters is 0, which tells us the surface there is shockingly fresh, replaced within at most the last several million years, and probably much more recently than that. On a world 4.5 billion years old, that is the same as saying it happened a moment ago. The ground out there is new, and there are signs the activity goes beyond the flowing ice. In some regions, New Horizons found large mounds with deep pits at their summits, structures that look very much like volcanoes, except that on Pluto a volcano would not erupt molten rock. It would erupt a slush of half-frozen water, an icy cryovolcano oozing material up from a warmer interior to freeze on the surface. We are not certain that is what they are, and the images we have are limited, but they point in the same direction as everything else. This is a world with heat still moving inside it, still reshaping its face, 4 billion years after it formed, on the cold edge of the solar system, where everything was supposed to have frozen solid and stopped long ago. Pluto did not get the message. It is still, quietly, at work. The heart itself is worth understanding as a whole, because it is more than one feature. The bright, smooth western lobe is Sputnik Planitia, the churning nitrogen plain with no craters. But the eastern half of the heart is different, a region where glaciers of nitrogen ice appear to be flowing out of the smooth plain and into the rougher, older land beyond, spilling through gaps in the surrounding highlands like frozen rivers leaving a frozen lake. You can trace the flow lines in the images, the slow outward creep of the ice carrying it from the deep central basin into the territory around it. The whole heart, then, is a single connected system, ice gathering and convecting in the basin, and then bleeding outward across the world. A slow circulation of frozen air on a scale of hundreds of kilometers. It is the closest thing Pluto has to weather written into the ground itself. And elsewhere on Pluto, the ice does even stranger things. In some high, cold regions, New Horizons found terrain covered in tall, thin blades of ice, fields of jagged ridges standing many stories high, packed close together like the teeth of an enormous comb. These blades are thought to be made of frozen methane, carved into spikes over long ages as the ice slowly turns to gas under the faint sunlight, leaving sharp standing fins behind. Nothing on Earth looks quite like it. A forest of icy blades taller than buildings, ranged across the slopes of a frozen world. Between the churning nitrogen plains, the flowing glaciers, the water ice mountains, the possible ice volcanoes, and these strange blades, Pluto turns out to have one of the most varied surfaces of any world we have ever mapped. Every region telling a different story, all of it under that dim and distant sun. This is the world that was supposed to be a featureless frozen rock. The colours of Pluto are worth seeing too, because they are not the uniform grey everyone pictured. Across its surface, Pluto runs from pale, almost white plains of fresh nitrogen and methane frost to deep, dark patches stained reddish-brown and even nearly black, where that haze chemistry has settled and built up over ages. Near the equator lie some of the darkest regions, long stretches given informal names that suit their brooding look, where the ground is the colour of old rust and deep shadow. Against them, the heart shines out pale and bright, freshly painted with clean ice. It is one of the most varied and contrast-rich surfaces in the solar system, a patchwork of light and dark, rust and cream, written across a world we expected to be a single dull shade of frozen grey. Even the colours of Pluto are telling us the same thing as everything else, that this is a busy, active, changing place, not a dead one. And high on some of Pluto's mountains, New Horizons saw something that stopped people in their tracks because it looked so familiar. Snow, bright caps of frost on the peaks, pale material clinging to the high ground the way snow gathers on mountaintops here. But this is not water snow, it is methane, frozen out of the thin air onto the cold high slopes, gathering on the heights of Pluto's ranges just as snow gathers on ours, for reasons that turn out to be much the same. A frozen world, 4 billion miles out, with snow-capped mountains, lit by a sun no bigger than a star. The more closely you look at Pluto, the more it rhymes with home in the strangest ways. The same shapes and patterns playing out in utterly alien materials at temperatures that would freeze the air solid. What gives a world this small the heat to stay active at all is the real puzzle, and it ties everything together. A planet stays warm inside in two main ways, from the leftover heat of its violent formation, and from the slow decay of radioactive elements buried in its rock. A small world like Pluto should have lost its birth heat long ago, bleeding it away into space over 4 billion years, the way a small cup of coffee goes cold far faster than a large pot. So the warmth keeping Pluto active today most likely comes from that slow radioactive decay, deep in its rocky core, a faint, steady trickle of heat that has kept some of the interior from freezing solid. It is not much, but on a world this cold, even a faint internal warmth is enough to drive convecting ice, flowing glaciers, and perhaps a buried sea, because there is so little competing with it. Pluto runs on the thinnest possible margin of heat, and somehow that margin has been enough to keep it quietly alive for the entire history of the solar system. The thing I keep returning to about Pluto's surface is how recent so much of it is. We are used to thinking of the outer solar system as ancient and unchanging, frozen at the moment of its birth and untouched since. Pluto breaks that picture completely. Parts of its surface are younger than our own species, ice that has been laid down and turned over in a span shorter than the time since the first humans walked the Earth. If you could somehow watch Pluto for long enough, you would see the plains slowly churn, the glaciers creep, the frost advance and retreat with its long seasons, a world genuinely in motion. That is the deepest surprise of all, deeper than any single feature. Not that Pluto is strange, but that it is active, still doing things, still changing its own face, at a distance and a temperature where we were certain nothing could. The edge of the solar system is not asleep, at least this one corner of it is wide awake. None of this should be happening. That is the point, and it is the real reward of having gone all that way. A world this small, and this cold, and this old, has every reason to be a dead, cratered rock, and instead it is one of the most geologically active places we have ever seen, its surface flowing and churning, and renewing itself under a sun that is barely a spark in its sky, which raises the question that pulls us deeper. What is powering all of this? Where does a frozen world 4 billion years old find the heat to keep its surface alive, and what might be hiding underneath it? The first surprise above Pluto's surface is the sky itself. When New Horizons looked back at Pluto with the sun behind it, it caught the thin atmosphere lit from within, and the haze glowed blue, a soft blue sky, layered in delicate bands rising high above the surface on a world 4 billion miles from the sun. That blue comes from the same basic physics that colours our own sky, sunlight scattering off tiny particles suspended in the air, except here the particles are a haze of complex molecules built by sunlight breaking apart the nitrogen and methane. The atmosphere is desperately thin, almost all nitrogen, 100,000 times fainter than ours. But it is real, it has weather of a kind, and it hangs over the ice in blue layers you could stand beneath and look up into. That atmosphere does something else that ties straight back to the shrinking sun. As Pluto moves along its stretched orbit, farther from the sun and then nearer, the tiny bit of warmth it receives rises and falls, and the atmosphere responds. When Pluto is closer in, some of the surface ice warms just enough to turn to gas and thicken the air. As Pluto swings back out toward the cold, that gas freezes again and falls to the ground as frost. The atmosphere of Pluto literally snows out of the sky and settles onto the surface as the world drifts farther from the sun, then lifts again when it returns. An entire atmosphere that comes and goes with the seasons of a 248-year orbit, breathing out and freezing back down in the most distant cold. But the deepest surprise is not in the sky. It is far below the ice, and it is the reason this section exists. There is real evidence that Pluto hides an ocean of liquid water beneath its frozen shell. Liquid water, kept from freezing solid, on a world where the surface is cold enough to freeze the air. The heat to keep it liquid would come from inside, from the slow decay of radioactive elements locked in Pluto's rocky core, a faint internal warmth that never quite lets the deep water freeze. And the clues point right back to that great heart-shaped basin. Here is the reasoning, because it is genuinely clever. Sputnik Planitia sits in a very particular spot on Pluto, almost exactly on the opposite side of the world from Charon, Pluto's big moon. That alignment is unlikely to be chance, and the best explanation is that the basin is heavier than its surroundings, a concentration of extra mass that slowly rolled Pluto over until that heavy spot settled into line with Charon's pull. But the basin is a low, deep hole filled with ice. What could make a hole full of ice heavier than the land around it? The answer that fits best is a bulge of liquid water pushed up beneath it, because liquid water is denser than ice, and a sea welling up under that basin would add exactly the missing weight. On top of that, the surface across Pluto is laced with long cracks and ridges, the kind of tension marks you get when a global ocean slowly freezes and expands beneath a crust, stretching the shell from below. Recent work even suggests that if the ocean is there, it may be dense and salty, a buried sea of cold brine. And that raises a question almost no one would ever have thought to ask about Pluto. A reservoir of liquid water, kept warm for billions of years, is exactly the kind of place we go looking for life elsewhere in the solar system. On ocean moons like Europa at Jupiter and Enceladus at Saturn, worlds with seas hidden under ice, Pluto, the frozen afterthought at the edge of everything, may belong to that same club of buried ocean worlds. I am not telling you there is life on Pluto, and I want to be careful here, because this is the live edge of what we know. The ocean itself is inferred, not confirmed. We have not drilled through that ice or measured that sea directly. We have read it from the position of a basin and the cracks in a crust. The blue of Pluto's sky is worth understanding because it is doing something subtle. High in that thin air, sunlight, faint as it is, strikes molecules of nitrogen and methane and breaks them apart, and the fragments recombine into larger, stickier molecules, a kind of complex soot that drifts and clumps into a fine haze. These particles are reddish-brown, where they gather thickly, and they are what coats parts of Pluto and Charon in rusty colour. But suspended high in the atmosphere, catching the distant sunlight, that same haze scatters blue light toward us, which is why the layers glow blue when seen against the dark with the sun behind. So the soft blue sky and the reddish stains on the ground are made of the same stuff, the slow chemistry of sunlight working on a frozen world's thin breath. Even out there with the sun a mere point, light is still quietly painting the place. The atmosphere is also stranger than its thinness suggests, because Pluto's gravity is so weak that the air does not stay neatly close to the ground. It puffs up enormously, extending hundreds of kilometers into space, far higher above its surface than our own atmosphere reaches above Earth, a bloated, tenuous envelope barely held down at all. And at the very top, some of it leaks away into space entirely, the lightest molecules drifting off because Pluto can barely hold them, a slow, steady bleed of nitrogen escaping the world and, in part, crossing over to stain Charon, an atmosphere that snows down as frost on one side of its long orbit and quietly evaporates into space at the top, all at once. Nothing about Pluto sits still. The evidence for the hidden ocean is worth laying out a little more, because it is a genuine piece of detective work read from the surface. Beyond the heavy basin and its suspicious alignment with Charon, there is the matter of the cracks. Across Pluto, and across Charon too, the surface is marked with long faults and ridges, places where the crust has clearly been pulled apart and stretched. That is exactly what you would expect if a global ocean beneath the ice had been slowly freezing over time, because water expands as it freezes, pushing outward on the shell above and cracking it like the surface of an overfilled pond. On the far side of Pluto from the Great Basin, New Horizons even glimpsed a jumbled, broken region, a chaotic terrain of ridges and pits, the kind of disruption a shifting ocean below could produce. None of it is proof. All of it is consistent with a buried sea, and honest scientists genuinely disagree about whether that sea is really there, or whether an ancient impact alone could account for what we see, which is exactly the kind of open, arguable question that makes a world worth going back to. I want to be careful not to oversell the ocean, because there is a long road between a buried sea and anything living in it. On Earth, life seems to need not just liquid water but a source of energy in the right chemistry, and a dark ocean sealed under many kilometers of ice cut off from sunlight entirely, is a hard place to make a living. On the ocean moons we compare Pluto to, the hope rests on heat and chemicals welling up from a rocky sea floor, feeding life in the dark the way it does around the deep vents of our own oceans. Whether Pluto's core could provide anything like that, billions of years on, with its internal heat fading, is completely unknown. So when I say Pluto might belong to the family of ocean worlds, I do not mean it is likely teeming with life. I mean it has crossed the first threshold, the presence of liquid water that we once thought impossible this far out. And that alone is enough to make it a place worth asking the question. The honest position is that Pluto went from obviously dead to genuinely uncertain, and uncertain this far from the Sun is already astonishing. It helps to look at Pluto's near twin to see how alive these frozen worlds can be. Far closer in, Neptune has a large moon called Triton, almost the same size as Pluto, made of much the same ices, and very likely a captured cousin from the same frozen population Pluto belongs to. When a spacecraft flew past Triton decades ago, it found dark plumes erupting from the surface, geysers of nitrogen gas blasting kilometers into the thin sky on a world just as cold as Pluto. If Triton can do that, then activity on Pluto should be no shock at all. These distant ice worlds, it turns out, are not the dead leftovers we assumed. They hold heat, they vent gas, they flow and crack and resurface, each in its own way, all of them far more alive than a world that cold has any right to be. Pluto is not the strange exception. It may be that the whole frozen frontier is quietly, slowly active, and we simply never looked closely until now. The blue haze has one more consequence worth noting, because it shows how active even Pluto's thin air really is. Those haze particles, forming high up and slowly drifting down, settle onto the surface over time, adding to the reddish material that darkens parts of the world. So the atmosphere is not a sealed, separate thing floating above the ground. It is constantly feeding the surface, raining down a fine soot of complex molecules built by sunlight, while at the same time gases rise off the ice to replenish the air. Surface and sky are locked in a slow exchange, ice turning to gas and rising, haze forming and falling back, the whole thin envelope cycling material down onto the world and lifting it again, year after year, across Pluto's long seasons. For a world we expected to be frozen into total stillness, there is a surprising amount going on between its ground and its sky, all of it driven by the faint touch of a sun that is barely there, even at the edge of the light. That little warmth is enough to keep Pluto quietly breathing. It is worth saying plainly why the possibility of an ocean changes how we should think about Pluto. For most of the time we have known Pluto existed, it was filed away as a frozen leftover, a dead chip of ice at the edge of the sun's reach. Interesting mostly because it was far. The hint of a buried sea moves it into very different company. It puts Pluto on the same short list as the handful of worlds where we seriously wonder whether the conditions for life might exist. Alongside ocean moons we are planning whole missions to study. That is a stunning promotion for a world we nearly stopped thinking about. It does not mean Pluto has life, and I want to keep saying that, because the leap from liquid water to living things is enormous, and we have no evidence Pluto ever made it. But it does mean that the question is now worth asking out there, 4 billion miles from the Sun, in a place we had written off entirely. And that shift, from dead certainty to honest uncertainty, is one of the real gifts of having gone to look. And there is a real counter-argument worth respecting. A study in 2024 argued that a giant ancient impact could have produced that heavy basin and rolled the planet over with at most a very thin ocean underneath, or perhaps none at all. So whether Pluto truly hides a sea, and whether anything could ever stir in it, is genuinely open. One of those questions where honest scientists look at the same world and disagree. I lean toward the ocean being real, because the cracks and the alignment fit it so well, but I hold that loosely, and you should too. What is not in doubt is that Pluto turned out to be a world worth arguing about, which is the last thing anyone expected of it, and it does not even travel through the dark alone. Pluto has a companion, and the two of them together are unlike anything else we know. Its name is Charon, and the first thing to understand is how big it is. Charon is about half the diameter of Pluto itself. Half. No other moon in the solar system is anywhere near that large compared to the world it circles. Our own moon is about a quarter of Earth's width, and we already think of that as unusually big. Charon, next to Pluto, is a giant so large that calling it a moon almost undersells what it is. And because Charon is so large, it does something no ordinary moon does. When a small moon orbits a big planet, it swings around the planet's center because the planet so completely dominates. But Pluto and Charon are close enough in size that neither one truly dominates the other. Instead, they both orbit a point in the empty space between them, the shared balance point of their gravity. The way two people swinging each other around by the hands both circle the empty space in the middle, rather than one circling the other. That balance point sits out in the open, above Pluto's surface, in the gap between the two worlds. Pluto and Charon wheel around that empty point together, locked in a slow waltz, which is why they are often called not a planet and a moon, but a double world. It is the only example we know of where the point everything turns around floats in space outside both bodies. They are also locked face to face. Pluto always shows Charon the same side, and Charon always shows Pluto the same side, the two of them turning in perfect step every 6 and a bit days, each hanging motionless in the other's sky. From the near side of Pluto, Charon would sit fixed in one spot overhead, never rising and never setting, a huge pale disk many times larger than our moon looks to us, always there, always showing the same face. From the far side of Pluto, you would never see Charon at all. You could live your whole life on the wrong side of Pluto and never once know that an enormous partner world hung over the other hemisphere. Charon is a strange world in its own right. It has a great red stain across its north pole, a rusty cap unlike anything on the rest of its grey surface, and the explanation is one of the stranger relationships in the solar system. That red material came from Pluto. Gas escaping from Pluto's thin atmosphere drifts across the gap between the two worlds, reaches cold Charon, and freezes onto its pole, where sunlight slowly cooks it into reddish compounds. Charon is in a real sense being painted by Pluto, stained over ages by the breath of its partner, two worlds so close that one slowly colours the other. And the system does not stop at 2. Circling beyond Chiron are 4 more moons, small ones named Nix, Hedera, Kerberos and Styx. These are not neat round worlds, they are small, lumpy, oddly shaped bodies, and they do something genuinely odd. They tumble. Instead of rotating smoothly the way most moons do, they pitch and roll chaotically as they orbit, their spin never settling into a steady rhythm, partly because they are being tugged by the changing gravity of the two big worlds wheeling around that central point. If you stood on one of them, you could not predict where the Sun or Chiron would next appear in the sky, because the little world beneath you would be wobbling unpredictably as it went. Charon is worth looking at closely, because it is a substantial world in its own right, not a mere companion. It is bigger across than the entire state of Texas, a grey, cratered, ancient surface, and it carries one of the most dramatic features in the whole system. A great canyon, or rather a belt of canyons and chasms, runs across Charon's face, a tectonic gash so deep and long that it dwarfs anything of its kind on Earth. A scar that looks as though the little world was once stretched until its surface split open. And that may be close to what happened, because if Charon once had its own ocean that later froze solid, the expansion of that freezing would have cracked its shell from within, splitting the surface along exactly such lines. So Charon too may have had a buried sea, long ago, now frozen through, its death written across the moon's face as that enormous canyon. How the pair came to exist at all is its own story, and it echoes something close to home. The leading explanation is that long ago, something large struck the young Pluto, a giant collision that blasted a huge amount of material into orbit, and that orbiting debris gathered into Charon. This is very nearly the same story we tell about our own moon, which is thought to have formed when a great impact threw a ring of debris around the early Earth. The difference is one of scale. At Earth, the impact produced a moon a quarter our width. At tiny Pluto, the collision produced a partner fully half its size, so large that the two have circled each other as near equals ever since, a double world born from a single ancient blow. Standing on the right side of Pluto, the sky would be like nothing in human experience. Charon would hang there, fixed, enormous, many times the size our moon appears to us, never moving from its spot, showing always the same face, going through its phases in place as the distant sun crept around. It would never rise and never set, because the two worlds are locked together, each frozen in the other's sky, and the four little moons, Nix, Hydra, Kerberos and Styx, would be faint moving points among the stars, each one tumbling end over end in its own irregular way, so that their brightness would flicker and shift unpredictably, the only fast-moving things in that slow, fixed sky. It is a system with a stillness at its heart, the two great worlds locked staring at each other, surrounded by a handful of small worlds that cannot stop spinning. Nothing about it resembles the simple planet and moon we set out expecting to find. It is worth remembering that Charon is a place you could stand on too, and the view from there would be even stranger than the view from Pluto. From the near side of Charon, Pluto would hang enormous in the sky. A mottled disk far bigger than Charon looks from Pluto, never moving, going through its phases in place, painted with its pale heart and its dark patches. You would watch Pluto turn slowly beneath its own thin haze, always in the same spot overhead, a permanent companion filling a chunk of the sky. And like Pluto, Charon keeps one face turned toward its partner forever, so this view would never change, never set, never shift position. For as long as you stood there, two worlds locked eye to eye across the gulf between them, each pinned in the other's sky, turning together through the dark in a slow shared rhythm that has held for billions of years. The whole system, in fact, would be a difficult and beautiful thing to explore. A mission that actually stopped at Pluto would find not one world but 6 to study: Pluto and Charon and the 4 small tumbling moons. A compact little family spread across a region of space you could cross in a matter of days. You could, in principle, move among them, from Pluto to Charon to the little outer moons, studying each in turn, a whole frozen archipelago at the edge of the sun's reach. It is a richer prize than anyone imagined when Pluto was just a faint dot in a telescope, a single point of light that turned out, when we finally arrived, to be a doorway into an entire miniature system of worlds. And every one of them sits under the same shrunken sun, the same bright star giving the same feeble light, the whole little family huddled together in the cold at the threshold of the dark. It is worth pausing on how unlikely a system like this is, because it makes Pluto stranger still. Almost everywhere else, a planet dwarfs its moons, and the moons go around it like small things around a large one. For two worlds to be so close in size that they circle a point out in open space between them is genuinely rare, something we had never seen up close before reaching Pluto. It happened, most likely, because the ancient collision that made Charon left behind a partner almost as substantial as Pluto itself, rather than the small fragments that usually result. So the double world is a kind of accident, a particular blow struck in a particular way billions of years ago, frozen now into a permanent slow dance. And the 4 small moons orbiting beyond Charon were so faint and far that we did not even know they existed until the years just before the flyby, when sharp-eyed searchers turned them up one by one as we prepared to send a spacecraft through. Pluto kept its full family hidden until we were almost on top of it. The tumbling of those small moons is worth one more look, because it is genuinely unlike anything in the inner solar system. A normal moon like ours settles over time into a steady rhythm, keeping one face toward its world and turning once for each orbit. The little moons of Pluto cannot do this because they are being pulled by two large bodies at once, Pluto and Charon both, wheeling around that central point, so the gravity tugging on them is forever shifting. The result is that these moons spin chaotically, end over end, their rotation speeding up and slowing and changing direction in ways that never settle into any pattern. One of them turns so fast and so erratically that a day on it has no fixed length at all. If you lived there, the sky would be a genuine chaos, the Sun and Pluto and Charon wheeling through it on no schedule you could ever learn. It is a small, dizzying detail of a system that the closer we looked, kept proving stranger than anyone had dared to guess. Standing back, the whole Pluto system rewrites what we thought a small frozen world at the edge of the sun's reach could be. We expected a single dead rock, and we found a double world of substantial size, born of an ancient collision, locked face to face, trailing four chaotic little moons, painting one another with their escaping gases, every member of the family under the same shrunken sun. It is the kind of place that, before we went, would have been dismissed as too cold and too small to be interesting, and it turned out to be one of the most intricate and surprising corners of the solar system. That, more than any single fact, is what the journey to Pluto taught us. The distant, frozen, forgotten places are not necessarily simple or dead. Sometimes they are where the strangest things have been quietly happening all along, unwatched, for billions of years, waiting at the edge of the dark for someone to finally come and look. So this is what is actually out there, 4 billion miles away, where everyone expected a single lonely frozen rock, a double world, locked face to face, turning around a point in empty space, painting its giant moon red with its own escaping air, attended by 4 small moons tumbling chaotically through the dark. It is a whole intricate system, a little family of worlds, far richer and stranger than anyone imagined before we finally went and looked. And standing in the middle of it, on Pluto's ice, there is one more thing you would want to do, the thing that ties this whole journey together. You would turn around and look back the way you came, toward home. Stand on Pluto and turn to look back toward home, and here is what you would find. Nothing. You would not be able to see Earth at all. Our entire world, everyone on it, everything that has ever happened in human history, would be a single faint dot lost in the glare of the sun, sitting so close to that bright point of light, from Pluto's angle, and shining so dimly at that distance that your eye simply could not pick it out. Earth would be there, somewhere in the brightness, but invisible, swallowed by the very sun it orbits. We actually know what this looks like, because a spacecraft once turned around and photographed Earth from out in the dark, from a place far closer to home than Pluto, and even from there our planet was nothing but a single pale dot, smaller than a single point in the image, a speck you would miss entirely if you were not told it was there. That was from much nearer in. From Pluto, more than 3 billion miles farther out, Earth would be hopelessly lost, drowned in the sun's glow, long before any eye could find it. And the sun itself, the thing this whole journey has been measured against, has reached the end of its long shrinking. From Pluto, it is simply the brightest star in the sky, not a disk, not a source of warmth, just a single brilliant point, brighter than anything else up there, but a point all the same, giving a light dimmer than our twilight and no heat you could ever feel. This is where the image I started with finally lands with its full weight. You could stand on that nitrogen ice, lift your hand, raise your thumb against the sky, and cover the sun completely. And behind your thumb, hidden in that small blocked patch of sky, would be the sun and the earth lost in its glare, and every person who has ever lived, every place you have ever been, the entire human story, all of it tucked behind one thumb, held up against the dark. Sit with that for a moment, because it is the truest measure of how far Pluto is. Not the miles, which are too large to feel, but that single gesture, everyone you love, behind your thumb. And here is the part that resets everything. a fact I find almost harder to hold than the distance itself. Pluto is not the edge. We think of it that way, the last stop, the frozen border of the solar system, but it is nothing of the kind. Beyond Pluto stretches the Kuiper Belt, a wide ring of icy worlds, thousands upon thousands of frozen bodies orbiting out there in the dark, and Pluto is merely the brightest and best known of them, one member of an enormous crowd. New Horizons, after it flew past Pluto, kept going and flew past another of these bodies 4 years later, a small frozen world 1 billion miles farther out still, a lumpy reddish object left over from the birth of the solar system. And even that is not the edge. Past the Kuiper Belt, the distances open up into something far larger again, a region so wide that the numbers stop being anything a human mind can really hold. So Pluto, the place we call the far border of the solar system, the destination we have been straining toward this whole video, turns out to be closer to a doorstep than an edge. It is the last thing before the true outer dark begins. Not the end of the road, but the start of a far longer one. We crossed the entire known solar system to reach it, spent a decade of a machine's life getting there, and arrived not at the finish line, but at the threshold, with everything beyond it stretching on into a dark we have barely begun to map. The image of Earth as a single lost dot is not something I am inventing for effect. It is real, and it is one of the most quietly haunting pictures ever taken. Decades ago, a departing spacecraft far out past the giant planets was turned around to look back at the inner solar system, and in the photograph it sent home, Earth is nothing but a single pale point, a speck less than the size of one dot in the image, hanging in a band of scattered sunlight. Everyone who has ever lived was on that speck. Every war, every city, every ocean, every life, all of it contained in a point you could blot out with the smallest movement of a fingertip. And that was taken from far closer to home than Pluto. From Pluto, billions of miles farther still, the dot would not even be findable, lost entirely in the glare of a sun that has itself become a star. That is the view back, not a small blue marble, but nothing at all, an emptiness where home is too faint and too close to its star to see. The world beyond Pluto that New Horizons went on to visit is worth a moment, because it shows what kind of place Pluto really lives in. 4 years after the flyby, the spacecraft reached a small frozen object more than 1 billion miles past Pluto. A body shaped like 2 lumps joined together, 2 ancient chunks of ice that drifted into each other so gently, long ago, that they simply stuck, rather than shattering. It is a fossil from the birth of the solar system, untouched for 4.5 billion years, preserved in the deep cold. And it is just one of an enormous population of such bodies, the Kuiper Belt, a great ring of icy worlds stretching far beyond Neptune, of which Pluto is merely the largest and brightest known member. Pluto is not a lonely outpost at the end of things. It is the king of a crowded, frozen frontier, surrounded by countless smaller worlds we are only beginning to find. And past even that, the scale becomes something the mind genuinely cannot hold. Beyond the Kuiper Belt, the sun's influence stretches on through an immense, almost empty region thought to hold a great cloud of icy bodies, reaching a good fraction of the way to the next star. The nearest star beyond our own sun is more than 4 light years away, which is to say light itself, which took 5.5 hours to reach Pluto, takes more than 4 years to reach that next star. If Pluto is the doorstep, then the nearest star is a destination thousands of times farther still, a gap that makes the whole journey we have just traced look like a single step taken just outside the front door. That is the true shape of it. We strain the limits of what we can build just to brush past the doorstep, and the real dark begins where our story tonight ends. The cloud of icy bodies, thought to surround the whole solar system, far beyond the Kuiper Belt, is worth a moment, because it is where our comets are born. Every so often, one of those distant frozen lumps is nudged loose and falls inward toward the sun, and as it nears the warmth, it begins to evaporate, growing the glowing tail we see as a comet. So the bright comets that occasionally cross our sky are visitors from that far outer dark, pieces of the same frozen frontier Pluto belongs to, falling in from distances so great that a single round trip can take thousands or even millions of years. When you watch a comet, you are watching something arrive from the very region we have been talking about, the cold reservoir at the edge of the sun's reach, of which Pluto is only the nearest, brightest doorstep. And one day, fairly soon, our one outpost in that region will go quiet. New Horizons runs on a slowly fading nuclear source, and sometime in the years ahead its power will drop too low to keep its instruments alive or its voice strong enough to reach us. When that happens, we will lose our only working eyes anywhere near Pluto, and there is no replacement on the way, no second mission funded and built and ready to take up the watch. For the foreseeable future, once New Horizons falls silent, we will once again have no machine at all out at that distance, and Pluto will go back to being a place we have seen clearly for a single afternoon and never since. That is how thin our reach really is out there. One small piano-sized probe, soon to fall silent, is the entire extent of humanity's presence at the doorstep of the outer dark. We touched it once, and we are about to lose even that thread. It is worth letting the comparison with the nearest star really land, because it puts this whole video in its place. Everything we have talked about tonight, the 9.5-year crossing, the wall of stopping, the long cold dark, all of it is the story of reaching Pluto, a world whose light reaches us in about 5.5 hours. The nearest star beyond the sun is more than 4 light years away, which is to say its light takes more than 4 years to arrive. Not 5.5 hours, but 4 full years. Put those side by side in the gulf to Pluto, the distance that strains everything we can build shrinks to almost nothing, a few hours of light against a journey of years of light. If reaching Pluto, a few light hours away, is at the ragged edge of the possible for us, then reaching even the nearest star, thousands of times farther, is a different order of dream entirely, one this video does not even pretend to touch. That is the humbling frame around the whole question. We are struggling, at the very limit of our power, to cross a gap that is, on the scale of the stars, the smallest of first steps. Pluto is as far as our story goes tonight, and it is barely out the door. Which brings us finally back to the question this whole journey was built around. We have seen the distance, the crossing, the long dark, the wall of stopping, the strange living world and its double, and the view back at a home we cannot even see. So now, honestly, with all of it in front of us, could we actually go? Could people, and not just machines, ever truly reach Pluto? So, could humanity ever reach Pluto? Here is the whole answer, laid out plainly, and it depends entirely on what you mean by reach. In the simplest sense, we already have a machine built by human hands crossed the entire solar system and flew past Pluto and sent home photographs of its frozen heart and its blue sky and its tumbling moons. If reaching Pluto means getting a piece of our technology there and learning what it is like, then the answer is yes, we did it more than a decade ago. That part is history. But that was a machine, and it was a flyby, an afternoon's glimpse after 9.5 years of falling, with no way to stop. If reaching Pluto means sending people, stopping, standing on that nitrogen ice, and looking up at the sun reduced to a star, then the honest answer is much harder, and it is not yet yes. To put a human crew there would mean a crossing of at least a decade, probably more, through cold that would freeze the air, and a dark where the sun gives no warmth, and home is hours away even at the speed of light. It would mean keeping people alive and sane through years of that isolation, which we have never done and do not yet know how to do. And it would mean solving the wall, the problem of stopping at a world that offers almost nothing to break against, which alone pushes the trip toward 20 or 30 years or demands engines we have not built. So where does that leave us? I think the honest place to land is this. Reaching Pluto with people is not forbidden by physics, the way some things genuinely are. There is no law of nature that says it cannot be done. It is forbidden, for now, by time, by fuel, by biology, and by the sheer scale of the distance, which is a different kind of barrier, the kind that yields to centuries of work, rather than never yielding at all. Pluto sits right on the boundary between the reachable and the unreachable, close enough that we have already touched it once, with a machine that could not stay. Far enough that truly going there, the way we once went to the moon, standing on it, looking back, coming home, may be one of the hardest things our species could ever set out to do. And I keep coming back to what that really tells us, because it is the lesson hiding inside the whole journey, the one the shrinking sun has been teaching the entire way out. We call Pluto the edge of our solar system. It is no edge at all. It is the doorstep. And here is the humbling part. Even the doorstep is very nearly beyond us. We have built one machine that could reach it, and only by flying past without stopping, and we are still a long way from being able to send ourselves. If the doorstep is this hard, this far, this punishing, then the real outer dark beyond it, the Kuiper belt and everything past it, is a distance we can barely even talk about reaching, let alone crossing. That is not a reason for despair, and I do not want you to hear it that way. We did reach Pluto. That is an extraordinary thing, that a species on one small world built a machine, flung it across billions of miles, threaded it past a giant planet, and woke it after 9.5 years to photograph a world no one had ever seen clearly. That happened. We are the kind of creature that can do that. But reaching is doing a lot of quiet work in that sentence, and the gap between what a machine did in an afternoon and what it would take to stand there ourselves is the real size of the distance. I want to be careful with the word reach here at the end, because the whole video has been quietly pulling it in two directions, and you deserve to see both clearly. There is reaching, as in touching, getting something of ours to a place, learning what is there. By that meaning, we have reached Pluto, and it was a genuine triumph, one of the finest things our species has ever done. And there is reaching, as in going, a person crossing the distance with their own body, standing on the ground, looking back with their own eyes. By that meaning, we have not reached Pluto, and we are not close, and the gap between the two meanings is the real subject of everything we have talked about. A machine brushed it. No human has come within 1,000 times the distance. What I find genuinely worth arguing about is whether that second kind of reaching is even worth the cost. A robot feels no cold and no fear, needs no air and no company, and can fall through the dark for decades without minding it at all, and it sends home everything we have learnt. So a hard-headed person could say the case is closed, that we have already reached Pluto in every way that matters, and that spending a human life and an enormous fortune to plant a person on that ice would buy nothing the machines have not already given us. I understand that view, and I cannot prove it wrong, because on the level of pure information it may be right. But I do not quite believe it, and I will tell you why, and then leave it with you. I think there is a difference between a place we have measured and a place we have stood, and that the difference is not really about data at all. No one doubts that a machine saw Pluto, but there is something in a person being there, in a living mind standing on that nitrogen ice, under that tiny sun, and turning to find a home it cannot see, that a photograph can never quite carry back. Whether that something is worth a decade of a life and a fortune in treasure, I honestly cannot tell you. It may be that we never go, that Pluto remains forever a place we have touched only through our machines, and that this is simply the right and rational choice. Or it may be that someday someone stands there anyway, for reasons that were never really about efficiency. I lean toward hoping they do, but I hold it as a hope, not an argument, and I think the honest thing is to hand you the question rather than the answer. Sit with it. There is one more thing the whole journey leaves me thinking about, and it is about scale and humility rather than Pluto itself. For most of history, Pluto was the edge of the map, the last world, the boundary of the known. And the closer we looked, the more that boundary dissolved, until Pluto turned out to be not an edge but a doorstep, with an entire frozen frontier stretching out beyond it, and the real dark beyond that. I think that is the pattern of almost everything we learn about space. Every time we reach what looks like the edge, it turns out to be a threshold with something larger waiting past it. The solar system is bigger than the planets. The frontier is bigger than the solar system. The galaxy is bigger than we can cross, and on it goes. Pluto is a lesson in that, delivered at a distance we can almost, but not quite, reach. We strained everything we had to brush past it once, and it turned out to be only the beginning of the dark. I find that humbling rather than discouraging, but I will let you decide which it is for you. When I weigh it all up, the thing I keep landing on is that Pluto sits at a very particular place in our story. The exact line where looking ends and going begins. We have looked at Pluto now, truly looked and learned that it is a living, layered, surprising world. But we have not gone, and going may be the hardest thing we could attempt, right at the edge of what our machines and our bodies and our patience can bear. So Pluto stands as a kind of marker, the farthest place we have reached with our eyes, and very nearly the farthest we could ever hope to reach with ourselves. The boundary between the solar system we can study and the one we can only dream of crossing. Whether we ever step past that line, whether anyone ever stands on that ice under that tiny sun, is a question for a future I cannot see. But the line is real, and Pluto marks it, and that alone makes the cold little world worth everything it took to get there. So let me leave you with the honest question, the one I genuinely cannot answer for you, because it is not about physics anymore. If it could be done, at enormous cost, a one-way decade or more in the cold and the dark, to stand on Pluto's ice and look back at a sun you could hide behind your thumb, would it be worth it? Robots can already go, and they feel nothing, and they send back everything we have learnt. So is there a reason to send a person at all, to spend a human life crossing all that emptiness, just to stand where a machine already stood? I have my own answer, and I will not force it on you because this is exactly the kind of question reasonable people split on. I think there is a difference between knowing what a place looks like and standing on it, and that the difference is worth a great deal. But I understand the other view completely. Sit with it. That is the one part of this no telescope and no engine will ever settle for you. I think what stays with me most is not how cold Pluto is or how strange, but how far. We use that word far all the time for a long drive or a distant country, and it has almost no meaning next to this. Pluto is so far that the fastest machine we have ever built took 9.5 years to get there and could only wave as it flew past. So far that the sun, the thing every living thing we know is built around, shrinks to a single bright star you could lose among the others. So far that standing there at noon, you would be in a light dimmer than our twilight, on a world where the air itself freezes and falls as snow. And here is the part one keep turning over. Pluto is not even the edge, it is the doorstep. Beyond it the Kuiper belt runs on, and past that the real dark, where the distances stop being anything a mind can hold. We think of Pluto as the far border of our solar system, and it is closer to a first step than a final one. Could we reach it? A machine did, barely, for an afternoon. Could we send people, and stop, and stand on that nitrogen ice and look back? Maybe, someday, at a cost in years and risk that is hard to even picture. But every time I imagine that traveller turning to find the sky, I come back to the same small, cold fact. From out there, you could hold up your thumb and cover the sun, and everyone you have ever known would be hidden somewhere behind it. If you want to keep standing at the far edges of what we can reach, a subscribe keeps you out here with me.